Hello, guys. Welcome to Calculus 1 with Robert here at Citrus College. Today we're looking at a problem. It's a limit problem. In a precision archery game, the center of the bullseye is located at the coordinate x equal to 2. The game calculates a score value based on the player's horizontal aiming input using the function f of x is 3x minus 1. For a perfect true center hit, the score must be exactly 5. As a developer, you need to prove that as the player's input x approaches a center x equal to 2, the score f of x reliably approaches 5. Now, what we see here is a really center limit type of problem. And if we take the x value, where is your horizontal aim, close to 2 as x approaches 2, and then the function. Now you may see right away that I can perform direct substitution. Just plug the 2 in, and I get 3 times 2 minus 1, which is 5. And that way, based on the function, based on how the program calculates your horizontal aim, you're going to get a perfect score of 5 when your x is 2. Right? But what's even more interesting is that if you look at the problem, it says that you need to prove that as a player's input x approaches the center, the score is 5. Okay, so this actually changes the problem a little bit. It's not just asking us to calculate what the score is when x is 2 or approaches 2. Right? It's asking us to prove it. Then this problem essentially becomes a problem that is asking us to prove that the limit is equal to 5. All right, we are trying to prove the limit as x approaches 2 of the function 3x minus 1 is equal to 5. And this is going to require us to use the epsilon-delta definition. Now, in the textbook, and I want to say in most of the textbook, they have the traditional way of proving, which is a little more technical and while rigorous at the same time. So those definitions in the textbook are a little harder to comprehend for us in a first semester calculus class. So to do that, I want to introduce a 4-step process to help us prove a limit using the technical definition. Right. So the 4 steps goes like this. You have 4 parts: given, choose, suppose, and check. Now, this 4-step process gives us a solid structure where it almost feels like filling the blank to complete the proof. Now, while this might not give a lot of insights to what the definition is going to do, but it's going to give us a, a kind of like a nice intro, scratching the surface of the deeper meaning of a limit. Okay, so we're going to start by doing a little graph to show you what we're trying to prove. So let's say I have the line 3x minus 1, say right here, actually, right here. And then we have the point of interest is 2 comma 5. Let's say maybe about here. Let's say this is the point 2 comma 5. So when x is 2, y is 5. And what we're trying to prove is if I can land within some neighborhood of 2, then my y value will be in some neighborhood of 5. So let's say I have some neighborhood of 2, and let's call that delta. And let's say if I pick an x value that's inside the neighborhood of 2. And then if I go up and translate through the function, I'll be within the neighborhood of 5. And the neighborhood of 5 is called epsilon, the Greek letter epsilon. Okay, so this is the idea of limit. As we shrink the neighborhood of 2, the neighborhood of 5 is going to be smaller. And so when I say the neighborhood of 2, I'm referring to the x value or the distance delta. And then the neighborhood of 5 would be the distance epsilon. So we want to show that the relationship between delta and epsilon so that when I pick a number, an x value inside the delta neighborhood, my y value will be inside the neighborhood of epsilon. Okay, so here we go. This is the proof. Given some epsilon greater than 0. So we are assuming that the neighborhood of y is positive, right? Some positive number. Doesn't matter how big, doesn't matter how small. Right? We're just going to assume that it's positive. And we want to choose delta to be something. Now, this something is very interesting. It's going to be the last thing that we plug in because this is going to determine the relationship between delta and epsilon. All right, suppose. So we're going to suppose that my x value that we pick is inside the delta neighborhood. So first, we start with x minus 2. Okay. So I pick some random x value. I subtract 2, put them in the absolute value. That will give us the distance between the x value of my choice and the x value of 2. And we want that to be less than delta. So therefore, this assumption that we're making is that the x value that we pick is within the delta neighborhood. And we want to show that my y value is inside the epsilon neighborhood. Okay, so I want to show that my y value, which will be 3x minus 1, and 5. So the distance between the y value of my choice of x and 5, I want to show that it's within epsilon. But I can't just say, oh, okay, it's less than epsilon. Then done. We can't do that. We want to check that this is indeed true. So let's see. I'm going to simplify the inside first. So I got 3x minus 6. And then I can factor out a 3. I got 3 times x minus 2. Now here, I have two different numbers multiplying inside the absolute value. I can factor the 3 out and put it in its own absolute value like this. Now I know the absolute value of 3 is 3. Okay, so I can just drop the absolute value like that. Now here's a very interesting step. I have 3 times x minus 2. Now, one thing we know about x minus 2 is that x minus 2 is less than delta. So if I take this inequality that I assume in the previous step, and if I multiply 3 on both sides, then essentially I get 3 times the absolute of x minus 2 is less than 3 delta. Now, because this was true, that means when I multiply 3 on both sides, this is also going to be true. Then I can say, okay, well, in my checking step here, I got 3 times absolute value of x minus 2. I can say that this is less than 3 times delta. And of course, remember that our goal earlier is that we want to show that the distance between my y value and 5 is less than epsilon. So at the end of the day, I want this 3 delta to be somehow related to epsilon. Because if I can make this happen, then essentially what I have shown is this thing that we started with is less than epsilon. So the final question is, well, how do we draw that connection from 3 delta to epsilon? Well, guess what? Let's scroll back earlier. Remember in step 2, we intentionally left delta blank. So we actually could pick delta to be anything. Well, in this case, well, what do I want delta to be? Well, what if I make it the easiest way possible? What if I won't make it 3 delta is indeed epsilon? And then I divide by 3. I get delta is epsilon over 3. So if I choose delta to be epsilon over 3, let's see what happens. The 3 delta here becomes 3 times epsilon over 3. Well, in that case, 3 times epsilon over 3 is epsilon. And there you go. It works because when I have delta being equal to epsilon over 3, this whole thing is now true. I have the distance between my y value and 5 is less than epsilon. So I'm now going to go back to the beginning, or it's not the beginning, step 2. And in this step 2, I want to choose delta to be epsilon over 3. And once you fill in this epsilon over 3, we are done with the proof. And let's go back to the end, and then we're going to add a little box, symbolizing that we're done with the proof. Okay, so let's go back a little bit and look at these 4 steps again. Now everything is filled in. Given some epsilon is greater than 0, I have some neighborhood of y value, neighborhood of 5, and I want to choose delta to be epsilon over 3. Okay, so here when we look at step 2, we are saying delta is epsilon over 3 right away. We are declaring the relationship between delta and epsilon. Step 2, suppose that the absolute value of x minus 2 is less than delta. Right? This is saying that my x value that I pick is within the delta neighborhood of 2. And then the checking step, I want to check that my y value based on the x value of my choice is within the epsilon neighborhood of 5. So that's why I'm subtracting the 5 here in the absolute value. That gives us the distance between the y value and the 5. Okay, it's equal to that, it's equal to that, it's equal to all of this. And then this is a crucial step. We're saying that we show that, okay, the distance is actually less than 3 times delta. And because we chose delta to be epsilon over 3, this is also saying that it's less than 3 times epsilon over 3, which is indeed less than epsilon. And notice I said less than for these 3 terms because I introduced the less than right here. That means that everything before, everything to the left of this inequality symbol is less than everything to the right of the inequality symbol. And that's how we make this work. And there you go. By definition, here we can say by definition, the limit as x approaches 2 of 3x minus 1 is equal to 5. And it's not by direct substitution. Now, every question in math requires work, requires practice and mistake. So I'll see you next time, and let's keep making mistakes.